Welcome to the third lecture in the week 12 of the course Basics of Mechanical Engineering 3. In this week, we are talking about the statistics in mechanical engineering. We have talked about the general introduction to statistics, what are the limitations, what are the kinds of statistics. We talked about the descriptive statistics and the data presentation ways and the way you present the pictorial or graphical data in the part 2. Part 3, we talk about basics of inferential statistics. As we talked about, inferential statistics takes some assumption and see whether that assumption is true or not. That is, we define and then work upon the hypothesis. In this lecture, the slides will flow like this. We'll talk about sampling techniques, a very general information or discussion about the kinds of sampling techniques which are there that we'll try to talk about. We talked about random sampling, some other methods we will also just see what other kinds of. Inferential statistics will give some more information on that. Then this lecture itself is majorly focused on inferential statistics and what do we need to do, what are the steps in investigations. Probability distribution, we'll talk about only Poisson, binomial and normal distribution. A quick introduction to Poisson and binomial because these are also used. The most widely used distribution is normal distribution, that we will discuss in little detail. Then we will try to see what is hypothesis testing, what are type 1 and type 2 errors, type 1 and type 2 errors. This part also we will see. First is sampling techniques. Sample collection out of population is called sampling. Sampling is done in many ways: probability sampling, simple random sampling, stratified, cluster, non-probability, haphazard or quota sampling. Probability sampling is that when each and every unit of the population has something known, that is a known chance, but a non-zero chance of being selected. For example, there is a big bucket of nozzles which are manufactured. There are maybe 5,000 buckets. You randomly just select 5 out of them. So, this is probability sampling. Simple random sampling is very similar to probability sampling. It says it has equal chance. The example which I gave is also an example of a simple random sampling, and we pick, for example, 5 pieces out of the 100 sets in a basket. Then comes stratified random sampling. Stratified random sampling means we divide the overall population into strata. For example, there are 1000 pieces in the bucket. We do not keep 1000 in one day. We just keep each hour, suppose for the 10 hours the production is happening. For the first hour we keep first 100 in one box. For the second hour we put second 100 in other box. For the third hour we keep the third 100 in another box. Total 10 boxes into 100 pieces. Then we pick, suppose, one sample from each of the boxes. This is known as stratified sampling. From each strata it is given. If the box size is bigger, or in a way if the number of units in that box is more, accordingly or proportionally we will pick. For example, one box is having 200 units, we will pick 2 out of them. Another box is having 100 units, we will pick 1 out of them as a sample. This is stratified. Then comes cluster sampling. Clusters are made based upon the kinds of similarity between the specific kinds of the units. For instance, there are 3 different machines which are there, which are manufacturing a specific set of the nozzles. For one machine it could be one cluster, for second machine it could be second cluster, for third machine it could be third cluster, or for different factory, if it is coming from different factories it could be in separate clusters. So, that is kind of a cluster sampling. We will put specifically or pick specifically from a specific kind of the set of the units. Non-probability sampling, it is exactly opposite to probability sampling. That means not all the units have a chance of being selected. It depends upon the researcher's judgment or convenience. So, these both non-probability and haphazard sampling is known as convenience sampling. Depends upon the researcher's judgment or experience. Then comes quota sampling. Quota sampling could be a specific quota is given to the specific set. For instance, I talked about the cluster sampling given different machines. Now, for instance, there are workers who are working, worker with more than 10 years of the experience, worker with less than 5 years of experience. 40% of workers are less than 5 years of experience, 60% are, for example, more than 10 years of experience. Accordingly or proportionally, I will pick the sample size based upon which worker has worked in what kind of the machines. So, that is quota sampling. Generally, we will talk about simple random sampling only, that is equal chance of the occurrence or equal chance of being selected. Sampling distribution. Sampling distribution is the probability distribution of all possible outcomes due simply to chance based on assumption that the null hypothesis is true. I will talk about what is null hypothesis. Sampling distribution we are talking about. When the outcome becomes highly unlikely based upon pure chance, we reject the null hypothesis. In statistics, this low probability is kept at generally around 5%, that is 5% due chance. Now, probability if it is 5%, this is also known as the significance level. This P, that is 1 minus 5%, is confidence level. I will talk about what is null hypothesis. I am talking about a confidence and a significance level. While defining a problem or while working on a sample, because we are trying to pick some number of units only from the overall population, out of maybe 10,000 units, we have picked only 20 units to be tested. These 20 units should represent what overall 10,000 units are behaving like. For that, how much confident we are, we keep that confident level. Whatever we do, there could be a small error, but if we are 95% confident, we put our hypothesis accordingly, or maybe at 99% of confidence level. This is 99% confidence means 1% of the significance level. I will try to talk about it more and it will be more clear when I will try to talk about the normal distribution. Probability, just to give a quick definition once again, is the likelihood of occurrence of some desired result or outcome from the statistical operation. If the probability comes out to be low, we reject the possibility of random error. A significant result is one that is very unlikely if the null hypothesis is correct. Alpha level probability is required for significance. The most common alpha level is 5%. If there is less than 5% chance that the results were due to random error, then the results are considered to be statistically significant. There are three types of probabilities majorly that we are considering in this lecture: Poisson, binomial and normal. Poisson probability or Poisson probability distribution talks about the chance of a given number of events occurring in a fixed time interval, assuming that it occur at a constant average rate and independent of each other. See the examples. Number of motor accidents at a specific juncture per month. This could have a Poisson distribution. Occurrences of power cuts in a week or a month. Poisson distribution. Number of calls placed by a call service employee per hour, that is within a specific time interval. Number of occurrences are happening, that is Poisson distribution, Poisson probability. Binomial is generally yes or no. It is probability distribution with n parameters asking yes no question and each of its own Boolean valued outcome, success with probability p or failure with probability q, that is 1 minus p. Binomial distribution is the basis for the binomial test of statistical significance. Examples are calculating probability of getting desired successful versus unsuccessful results, measuring the chance of getting one result over another in defined experiments. These are not much detailed. Anyway, we will be given more references to read more about binomial Poisson. Third one, which is normal distribution, that I will give you more detail about because we are going to talk about the hypothesis testing based upon this only. In all statistical models, we generally assume that experimental data errors are normally distributed. This assumption can be verified by plotting the residual errors on a normal probability distribution. If all the residuals falls along a straight line drawn, it is said to be normal distribution. Normal distribution says, I took the example of the students in the class, average height is 5 feet 8 inches, maximum height would be something, minimum height would be something, but most of the students are 5 feet 8 inches. This is called normal distribution. For instance, if it is like this, most of the students are of height 5 feet 8 inches, and minimum is suppose 5 feet 2 inches, maximum is suppose 6 feet 1 inch something. Then most students would be 5 feet 8 inches, some students would be 5 feet 9 inches, then some would be this, one or two students could be 6 feet 1 inch, one student could be something like this. This kind of the histogram plot gives me a frequency polygon which I try to draw, gives me a distribution that is known as normal distribution. Normal means very common. Normal in literal terms means very common. Commonly most of the data is just distributed like this. If you see average marks in the class, average dimension, whatever is the desired dimension, average dimension, most of the pieces would fall into that. Some of them would be larger, some of them would be smaller. So, this is normal distribution. And here this difference is sigma, standard deviation. This is mu, that is mean, and this is sigma, standard deviation. And mu minus sigma, mu minus 2 sigma, mu minus 3 sigma, each of them have a specific percentage of area lying within itself. For example, this is around 67% of area that lies between mu minus sigma and mu plus sigma. Let me see more about it. Normal distribution is a continuous probability distribution. It is a distribution of continuous variables. A continuous variable is variable that can assume any value on a continuum, and that can assume an uncountable number of values. For instance, height, for example, measurement, the diameter, weight, these are all continuous variables. These are only where normal distribution could be plotted. For the variables for which continuous variable is not there, for instance, the dimension could be 2.5 micrometer, 2.51 micrometer, 2.512 micrometer, 2.513 micrometer to any level. This is a continuous distribution. Non-continuous distribution is when the numbers are there. For example, number of machines, number of workers, number of boxes which are ready. That is the non-continuous distribution. So, normal distribution is for a continuous variable. For example, thickness of an item, time required to complete a process, temperature of a system, etc. Such parameters can take on any value depending on the ability to measure them precisely and accurately. Normal distribution, the characteristic of normal distribution are the curve is bell shaped and symmetrical about mean. This is bell shaped curve, it is symmetrical about mean. The mean, median, mode are all equal. This is, as I said, you see in this number of students, for example, 5 students are there, it is a frequency which are having height of 5 feet 8 inches, and there are 3 students who are having height of 5 feet 7 inches and 5 feet maybe 10 inches, and there is only one student of height 5 feet 2 inches. So, this is mode, maximum number of students. Also, this is median, and also this is a continuous variable, this is also mean. This means mean, median, mode are all equal in normal distribution. Mean, median and mode coincide. The total area under the curve is 100%. The tail on either side of the curve extends to infinity, it never touches here, never touches the baseline, or it touches the baseline at infinity. The distribution is defined by two parameters, mu and sigma, where mu is mean, that is location is determined by the mean mu, and spread is determined by the standard deviation sigma. The random variable has an infinite theoretical range, that is plus sigma to minus sigma. The tails of the curve extend to infinity, but they do not touch the axis. So, these are characteristics of normal distribution. Standard normal distribution is a special case of normal distribution where mean is 0, standard variance is 1. Suppose x is a continuous variable or random variable, that is the normal distribution, that is n mu sigma square. This is the way to present the normal distribution. Then random variable z follows a standard normal distribution, that is z is equal to x minus mu by sigma. There is z, that is the coefficient of sigma here in the normal distribution which I showed, this minus 1, minus 2, minus 3, 1, 2, 3, 0. This is z score. This is Z score. Horizontal axis is represented by Z. Center point is the mean 0. The Z value at a point X on the horizontal axis gives the distance between the mean and that point in the terms of standard deviation. This is the standard normal distribution with mean 0 and variance as 1. So, let me see an example here. Normal probability plot is generally generated in the following way. Arrange the sample data in the ascending order of magnitude. Compute the cumulative frequency, that is j minus 0.5 by n. I will show you the example in the next slide. J is the rank or position of the number in ascending order and n is the total number of observations. Transform the cumulative frequency into standardized normal score Zj. Plot Zj versus Xj. So, let me see this example. Let us consider the hardness of 10 samples of a certain alloy steel having undergone heat treatment processes. This 290, 248, 235, 228, 256, 223, 263, 195, 272, 237. Here the minimum value is 195, maximum value is 290. To obtain a normal probability plot, we tabulate it for normal probability plot. We will tabulate it. There are 10 numbers, we put the numbers from 1 to 10 here. Then we arrange data in an ascending order value, that is in the second column, that is the minimum value is 195, maximum value is 290. It is put in an ascending order. Then first column indicates the rank of the ordered data, third column gives the cumulative frequency of the ordered data. Cumulative frequency, that is j minus 0.5 by 10, that is number of samples. This I got it here. Based upon this cumulative frequency, I get the value of Zj, and this Zj is now plotted here. You see, this is Zj and this is probability or frequency. The plot Xj, that is the x-axis versus j minus 0.5 by 10, that is y-axis, is the normal probability distribution plot. We can also plot Xj, that is x-axis versus zj or y-axis in an ordinary graph sheet to obtain the same result. This is plotted here, hardness here. Let me see another example to having more understanding about the bell-shaped curve of normal distribution. It is given here, the diameter of shaft manufactured is normally distributed with a mean of 3 cm and standard deviation of 0.009 cm. The shafts that are with 2.9 cm or less diameter are scrapped and shafts with diameter more than 3.02 cm are reworked. Determine the percentage of the shafts scrapped and percentage of the shaft reworked. Could you see this scenario? The central mean is given. We have the lower value, that is 2.9 centimeter. Below that it is scrapped. We have the higher value, that is 3.02 centimeter. Above that it is reworked so that we reduce the diameter. Now, this mean value and these two values, which are the extreme values which I have given, below which it is scrapped and above which it is reworked, these could be plotted in a normal distribution. Let us see how. Mean is 3 centimeter, standard deviation is 0.009, upper limit is 3.02 centimeter, lower limit is 2.98 centimeters. Now, let us determine z value corresponding to upper and lower limit. This z value is calculated as I gave you the formula. It is x minus mu by sigma. Z was this. So, where x value is the upper limit here, that is 3.02 minus 3 by sigma. This is the z value on the higher side, and L minus mu by sigma, this is 2.98 minus 3 by 0.009 is minus 2.22. This is sigma value on the left hand side. So, from the standard normal distributions, that is probability distribution tables, we see the probability for the z value. At this value, the probability is 1.32%. The percentage of rework is 1.32, that is we have marked this minus 2.22, this is z score. Here mu is equal to 0, here it is z score of plus 2.22, and here on the left hand side you see 1.32% of the shafts are scrapped, it is given here, and 1.32% is reworked here. so that we reduce the diameter to exactly 3 centimeters. This is a standard normal distribution. Just to show you the standard normal distribution table at minus 2.22 and 2.22, what are the values? Let me see. At minus 2.22 and 2.22, you see this is given 0.5 minus 0.4868. This is the area that we have seen in this table. In this table you see, we can see 2.2 is here. From this 2.20 is this, 2.21 is this, 2.22 is this, 0.0898. So, this is talking about area on the left hand side of this area. This total area is 0.9868, which means this half of the area would be 0.9868 minus 0.5, which is 0.4868. And we are interested from this half area, we are only interested in this region that is on the right hand side. This region is what? 0.5 minus 0.4868. I am talking about this region only. This came out to be 0.0132. You see it here. We are looking at right side, this area comes out to be 0.0132. And on the left hand side, if I see at minus 2.22, another standard normal distribution is here, in which we are showing the area on the left hand side. This will be directly given, because directly we are given. So, we have minus 2.22 here. If you wish me to zoom this, I can also zoom this so that is more visible. This is minus 0.22 at this side. From here 2.20, 2.21 and little this side 0.0132. So, to put it in the slide mode, so this is at minus 2.22 to this level, at 0.22 this level, this is the value, directly 0.0132. This gives me the percentage of scrap as 1.32%, percentage of rework which is on the right hand side as also 1.32%. Had it been a different value, for example, had it been a value of maybe minus 2.24 on this side, then we would have taken, I am putting had it been, just to make it more clear, minus 2.24, we would have taken the percentage as, let me see in the table, in the green color, this value would have come 0.0126. This value would have come. So, in that case, this would have been 0.0126, which is equal to 1.26%. This is just a separate note I have given. So, this is how we used standard deviation and normal distribution, and hypothesis testing is having lot of application in this. Hypothesis, one-tailed on left hand side, twelve-tailed or right hand side, or two-tailed test. These are all having different tables, and from those tables itself we try to see the value and try to see what is the area of acceptance region and where do we reject the hypothesis that try to accept the alternative hypothesis. Now, having understood the normal distribution, let me talk about inferential statistics, that is hypothesis testing, in little more detail. Inferential statistics is an important tool that allows us to make predictions and conclusions about a population based upon sample data. Descriptive statistics only summarizes the data, while inferential statistics let us analyze data by testing hypotheses, making estimates and measure uncertainty about our predictions. These tools are essential for evaluating models, testing assumptions and supporting data-driven decision making. Inferential statistics provide tools to analyze conclusions systematically and mathematically, and these gives the probability that the difference between the means reflects the random error than a real difference. So, what can inferential statistics do for us? Because analyzing entire population is very time consuming, that is census survey needs a lot of resources, we collect the data from a sample population and use inferential statistics to conclude about the whole population, test hypotheses or claims, calculate confidence intervals and p-values, that is the probability values, to measure uncertainty and make predictions with statistical models. Now, the goal of inferential statistics is to draw conclusions from a sample and generalize them to the population. It determines the probability of characteristics of the sample using probability theory. The common methodologies are hypothesis testing and analysis of variance. I will talk about hypothesis testing, I will talk about regression modeling in the next lecture. For it is not feasible to gather data for large population, we collect information of count. We consider this sample for our statistical study for the whole population. This is known as sampling. That is the point where we started our lecture with. We specifically select the sample and try to conduct hypothesis testing over it. Now, what is an hypothesis? It is a statement about the value of a population parameter developed for the purpose of testing. It has to be evaluated to be accepted or rejected. Generally, we say it is rejected or not rejected. A procedure based on sample evidence and probability theory used to determine whether the hypothesis is a reasonable statement and should not be rejected or is unreasonable and should be rejected is done by: number 1, formulate a hypothesis about the population parameter, collect the sample data and calculate sample statistic, evaluate the hypothesis by determining the difference between the hypothesis parameter value and the sample value. We will see this through examples. Making a statement of hypothesis is very important. How clearly and how precisely we make this statement, that is very important. And there could be one-tailed and two-tailed test. I am talking about tails because the normal distribution has the ends which are called as kind of a tails of it. One-tailed test could be, for example, I took the example of a shaft of 3 centimeter of the diameter. If I say the size of the shaft is less than 3.02 centimeters, that's all, one tail, one side test only. Or if on the other side I say size of the shaft is greater than 2.98 centimeters, that is always a one tail test. I am talking about only one side. If I say size is different from 3 centimeter plus minus this distribution, this plus minus 0.2 value, this is both the tails are considered, that is two tail test. So, accordingly the area is taken in normal distribution. The type of hypothesis is null hypothesis. It represents a theory or assumption that has not been proven and is often used as a basis of testing. In a clinical trial, the null hypothesis might state that there is no significant difference between a new drug and an existing one. That can be written as H naught, which represent the null hypothesis. The new drug is no better than the current drug on an average. Now, what does this mean? If null hypothesis is rejected, that means there is no better than current drug statement is rejected. That means there is a significant difference that exists. If it is not rejected, this means it is a no better than the current drug. Alternative hypothesis is there which aims to prove that is an alternative way. Alternative hypothesis is when null hypothesis is rejected, there is an alternative thing that is true. It is a statistical test which aims to prove and is typically the opposite of null hypothesis. For example, in clinical trial, the alternative hypothesis might be that the new drug has a different effect than the current one, which is written as HA, that is alternative hypothesis. The new drug has a different effect than the current drug on average. The result of hypothesis test can be one of these two outcomes. Number 1, reject H naught in favor of HA, or do not reject H naught, that is we reject HA. Null hypothesis, let me see an example when we compare it with the alternative hypothesis. State the hypothesized value of the parameter before sampling, the assumptions we wish to test or the assumptions we are trying to reject. Population mean is equal to 10, this is null hypothesis. On the other hand, alternative hypothesis is all possible alternatives other than the null hypothesis, that is either mu is not equal to 10, that is both the sides two-tailed test, or mu is greater than 10 or mu is less than 10, both of them are one-tailed test. In null hypothesis, there is no difference of tensile strength between duralumin and mild steel. This could be a null hypothesis statement. There is no difference in tensile strength. Alternative would be there is a difference of tensile strength. That is, what we wish to prove or what we wish to work upon is alternative hypothesis, that there is a difference between the tensile strength. There is a lot that is to be rejected or accepted, alternative hypothesis. Deciding on a criteria for accepting or rejecting the null hypothesis, there is significance level, which refers to the percentage of sample means that is outside certain prescribed limit. For example, testing a hypothesis at 5% level of significance means we reject the null hypothesis if it falls in two regions of area of 0.025, that is in two-tailed test. When we say 5% significance level, as I said, significance level is exactly opposite to the confidence level. We are 95% confident that this is true, and if it is a two-tailed test like this, and if we say 5% of, I will put that S dot L dot, that significance level, that means 0.025 here and 0.025 on the right side. So total area is 95%, that is left inside. Do not reject the null hypothesis if it falls within the range of the area of 0.95. The higher the level of significance, the higher the probability of rejecting the null hypothesis when it is true, that is acceptance region narrows. That means whenever we move towards this, the acceptance region, this is acceptance region, this narrows. Let me see an example problem so that we are clear with it. The null hypothesis is that battery for an electric vehicle has an average life of 1000 days, with an alternative hypothesis that the average life is more than 1000 days. You are the quality control manager for the battery manufacturer. Would you rather make a type 1 error or type 2 error? These are new terms. I will talk about what is type 1 and type 2 error. These are the consumer and the producer errors. Based on your answer to part A, should you use high or low significance level? Please try to understand this problem. They say average battery life is 1000 days. This is what? This is our null hypothesis. Alternative will be, that is HA, that average battery life, it is not given not 1000, it is given more than 1000. We say alternative is average battery life is more than 1000 days, or we can also put it as H naught is mu is equal to 1000, or H alternative is mu is greater than 1000. Now they say, would you make type 1 error or type 2 error? For this, let me first talk about what are type 1 and type 2 errors. Hypothesis test is a simple rule that is either accepted or rejected. Since it is based on sample statistics computed from n observations, the decision is subject to two types of errors. The point I am trying to make here is only small number of observations is representing the whole population. For example, out of 10,000 pieces of the nozzles, we have picked only sample of 20. This 20 will represent the 10,000. Whatever is the outcome of this 20 sample testing out data, that would be projected over the 10,000 pieces. The whole lot would be either accepted or rejected based upon this. There could be an error that this sample we have selected is good, but overall lot is not good. Or on the other side, the sample we have selected is not good, but overall lot was good. In both the case, there are errors, that one of this type 1, one is type 2. Let us see those. Type 1 error is the probability that is noted by alpha. It says that the null hypothesis is true, but rejected. That is alpha is equal to P, H naught is rejected, but it was true. This is known as producer's error. This means the sample that is selected is not a good sample. The sample should have been accepted, that is H naught should be true here, but it is rejected. That is the sample is rejected. Based upon the sample, the whole lot of 10,000 pieces is rejected. Based upon what? Sample size of 20 pieces only. That means 10,000 pieces which the producer or manufacturer has produced have gone to waste. This is producer's risk because of the selection of a incorrect sample. This is type 1 error. On the other hand, there could be type 2 error, which is the probability that is denoted by beta, that is type 2 error. It says that hypothesis is accepted when it is not true. This is some alternative hypothesis is true. That is H naught is accepted when it should be false. This means the sample that is selected is a good sample, very wonderful sample and is accepted, but the lot is not good. Out of the bad lot, good sample is selected. Because of this sample, the whole lot is now selected and that is passed to the consumer. Now, producer will have its profit, but consumer will receive the products which are not good, 10,000 pieces which are not good. That means this is a consumer's error. So, these two errors are possible when we talk about the hypothesis testing. So, 1 minus beta is called the power of test, is denotes the probability of not committing type 2 error. So, now let me see the problem statement. They say, would you have a producer's risk or would you have a consumer's risk? Would you rather make, which kind of risk would you like to make? And just to be more clear, this 5% significance level is alpha. Alpha, wherever I have written, this alpha is significance level. Now, would we increase significance level or reduce it? This is the question asked. So, whether we will make type 1 error or type 2 error, this is the first part. Now, type 2 error is consumer risk. Even if this is rejected null hypothesis, still the battery life is more than 1000. That means, if H naught is false, comma, still mu is greater than 1000. Therefore, we would prefer making type 2 error. This is part A. Part B, should you use high or low significance level? Now, if we increase the alpha value, if we reduce the alpha value, what happens? When we increase alpha, there are more chances of type 1 error, and when we reduce, there are less chances of type 1 error. And when it comes to alpha, we will try to reduce the alpha value. So, the last topic I would like to discuss more details of the one-tailed and two-tailed test. We talked about the one-tailed and two-tailed test when we are talking about only one direction, whether the acceptance regions is only in one direction. For example, if I say the dimension is 2.5 micrometers, if I say less than 2.7 micrometers is acceptable only, that is one side only. Or if I say greater than 3.5 micrometers is acceptable only, something like that. So, this is one sided only. If I say, like I took the example in the previous plot here, this was half of the area on this side, half of the area on this side at 5% significance level. Had it been one tail test, it could have been This is the acceptance area. Acceptance region. And this would have been 0.05, that is 5% on one side itself. So, this first one is one-tailed test, this is two-tailed test. Let me try to see this with very small and easy examples. Let me try to talk about first lower tail test, then I will try to talk about the upper tail test. Lower tail test will reject the null hypothesis if the sample mean is lower than the hypothesized mean, that is H naught is mu is equal to mu naught, and H alternative is when mu is less than mu naught. So, we will reject if alternative hypothesis is true. For example, a wholesaler buys light bulbs from the manufacturer in large lots and decides not to accept a lot unless the mean life is at least 500 hours. When I say at least 500 hours, it looks like we are talking about the upper tail, but this is a lower tail test where we can design the null hypothesis as H where mu is greater than equal to 500. Because my focus is upon the lower tail test here, alternative hypothesis is what? That is has to be lower tail, that mu is less than 500. This is the alternative hypothesis. So, here phrase lower tail indicates alternative hypothesis should be less than sign. So, wholesaler is looking for an evidence against the null hypothesis here. The word at least means greater than equal to 500, this is null hypothesis. This means he rejects H naught only if mean life of bulbs is significantly below, just watch my words here, significantly below 500 hours, that is H naught is rejected, which means HA is accepted. This is one-sided test. Then we have upper tail test, which will reject the null hypothesis if the sample mean is significantly higher than the hypothesized mean. Here H naught would be mu is equal to mu naught and H alternative would be mu greater than mu naught. A highway safety engineer decides to test the load bearing capacity of a 20-year-old bridge. The minimum load bearing capacity of the bridge must be at least 10 tons. You see the design of the two examples which I am taking. Previous one was the bulb life should be more than 500 hours. If should be more than 500 hours, less than 500 hours is the alternative. Here it is the bridge design. If it is 10 tons minimum load bearing capacity, here alternative hypothesis based upon the upper tail test would be H alternative is mu greater than 10 tons. So, this means this uses upper tail test. Null hypothesis is then designed, null hypothesis is mu I could say is equal to 10 tons, or I could have even put mu is less than equal to 10 tons, any of those. But alternative hypothesis is mu is greater than 10 tons. So, here he rejects H naught only if mean load bearing capacity of the bridge is significantly higher than 10 tons. See these words. He rejects H naught only significantly higher than 10 tons. This is for upper tail. For lower tails, he rejects only if it is significantly below 500 hours. This is lower tail. Let us see an example of the two-tail test. Two-tail test will reject the null hypothesis if the sample mean is significantly higher or lower than the hypothesized mean. In this, the hypothesis null is given as H naught, that is mu is equal to mu naught. Alternative is mu is not equal to mu naught. It could be lower or higher, anything. The manufacturer of light bulbs want to produce light bulbs with a mean life of 500 hours. If the lifetime is shorter, he will lose customers to the competition. If it is longer, he will incur higher cost of production. He does not want to deviate significantly from 500 hours in either direction. This is more simple here. H naught is designed as mu is equal to 500 hours and H alternative is mu is not equal to 500 hours. And this is a two-tailed test. With this, I am closing this lecture. To recapitulate, we talked about what are the main types of the samplings, major types. We talked about the random sampling as the most used type, but we talked about only the kinds of stratified sampling, cluster sampling and other types. What is sampling and why the sampling is needed in research. Define inferential statistics in simple words. What is probability distribution used for? We talked about binomial, Bayesian, normal distributions, hypothesis testing and its purpose, difference between null and alternative hypotheses. With this, I am closing the third lecture. The last lecture of this course would be talking about design of experiments, where I will also talk about the regression analysis in some detail. Thank you.